Ladies and gentlemen, Sergey Yegorov, Alexey Nesterov, and Mr. David Syer. Gentlemen, welcome to our broadcast.
Thank you.
Hi, everyone.
Yeah. Sergey, could you please say a couple of words about yourself, and could you please introduce Alexey?
Hey, everyone. I'm Sergey Yegorov. I'm here as an invited expert, and also this topic will be about inner loop development in Kubernetes. I'm kind of Jon Snow of Kubernetes, meaning I know nothing about it, but it's still a pleasure for me to be here and to help David to present. And with big pleasure, I'm giving a stage to Alexey, who actually talk about David and explain who David is. But I'm happy to say that both are my ex-colleagues, and I got a chance to work with both of them. And it was a big pleasure to work with them. So I'm really looking forward to the talk. Alexey?
Yeah, thanks, Sergey. Yeah, it feels pretty much like spring engineering meeting now, right? With just two people watching.
Indeed.
Yeah, it's actually a great pleasure to be here again because it's my second day here at JPoint. And I don't really know much what to say about this the presentation. I don't know what it's going to be about. I guess it's going to be in a way about Kubernetes. So I'm not going to take your time, Dave. And it's actually to you now and to your talk.
Okay.
Thanks, yeah.
Yeah, so I have a couple of words to add just before we start.
Oh, okay.
Yeah. First of all, for the time being, I see only 15 attendees in our Telegram chat, and I want to remind to all the audience that under the player we have a Telegram button. It's yellow, so button with a Telegram icon. Please, all the attendees, push it, and join our Telegram chat. In Telegram chat, you can ask the questions. All the questions will be translated from chat to David via our invited experts, Alexey and Sergey. So, and what I'm waiting for more people in the chat. Sergey, Alexey, how many people do you see in the chat right now?
22.
22. It's too. I want more people in chat.
24.
I can only see 12.
No, I'm waiting for 30. I'm waiting for 30.
I blame eventual consistency. I bet it's in Mongo.
Yeah, that's why I'm asking you about. I have a bit different numbers. Okay, more people in the chat.
Like, show me 50. Now, next one, 75. I hear 75.
75-1.
But come on, people, join the chat.
Again, join the chat.
Chance to ask question to Dave.
Absolutely. That's a unique chance.
Yeah, don't be shy. And you can ask questions in Russian for sure. I won't be able to answer them that way. So
yes. The idea, yeah, for those who worrying about this, his or her English is not enough to ask questions, don't worry, just write it in Russian, and Sergey and Alexey will translate it to David. Don't worry about this. Okay, how many do we have right now? I have one more. I have 39.
39 I see as well, yeah.
I need one more.
They're getting impatient.
42. Okay, I think, okay, that's good. And we can start. Okay, ladies and gentlemen, again, Mr. David Syer. Dave, the broadcast is yours.
Dr. David Syer.
Dr. David Syer.
Yeah, you can use that if you want to. Yeah, my laptop just went to sleep. So, yeah, thanks, everyone. Thanks for the introductions. And, I just want to say, like Sergey did, that I've enjoyed working with these two guys over the years. Sergey has saved me many hours of fruitless messing around with Reactor and with test containers. And there will be containers in this presentation for sure. So you won't get away from one of your subject matter expert areas, at least, Sergey. Alexey and I have worked on various things, including Spring Kubernetes controllers on the cluster and some commercial products that VMware is working on at the minute. So, you guys, what's the weather like? What's it like in London?
It's, I would say, kind of a crazy mix of.
Oh, we're just doing a warm-up. We haven't finished warming up.
Yeah, I was just saying that actually in London, it's a crazy mix of very, very chill mornings and very, very nice days with the warm sunshine. And you never know, like,
to warm up, right? Yeah.
Yeah, so it's a bit insane, but I'm enjoying that.
I don't know why it's so cold at this time of year. It's really cold here.
It's fairly unusual, yeah.
Yeah, it's about 4 degrees cooler where I am than where you are.
Yeah. I hear sunshine and I'm jealous because in Berlin the weather is pretty much like in St. Fetersburg, and since we have many watchers from Russia, they understand the reference. But basically, the city of the rain is St. Petersburg, and that's how it feels right now in Berlin. But yeah, we're looking forward to better weather.
Oh, it's too bad. Oh well. Yeah, so I don't know. Should we get started? Do you want to ask any more questions before we get started? I can warm you up and tell you what we're going to do. Or... No? Okay,
I'm excited to see what you...
You're excited. We're all excited. Okay, so I'm going to start in a terminal. I'm assuming everybody can see that. And if you can't, then just shout. And let's see. So I've got some code that I've been working on. It's very simple code. Just hopefully we'll be able to follow along during the presentation. If you wanted to see it, it's in a Git repository. So you can see it there. GitHub.com, Syer is me, in a loop boot Kates. And I'm just going to open up the browser in the README. There's a README with this link in it, so I'm just going to open that now in a browser so you can see. There's the code. It's just a Spring Boot application, and there's a README with some notes in it that I'm just going to walk through, and we'll do a little demo as we go along. So we're going to talk about, or me, I suppose. I'm David Syer. I work for VMware, so that's my email address. I'm on Twitter if you want to shout at me. And here's the link for the code that I'm going to be talking about. So we are going to be looking at the inner loop, what I'm calling the inner loop, and I'll explain what I mean by that in a minute. Inner loop and outer loop. I'll show you how to get stuff set up. I'll show you the sample app, and we'll run it. We'll look at some Spring Boot features. We'll build a container for the app, and then we'll look at 3 or maybe, well, probably 2 or 3 different ways of building the inner loop. And I'm going to do it in an IDE, but I'll just stick to the browser for a minute while we talk about this. So what's the inner loop? It's a new term for me. I haven't used it very much, but we've started using it in VMware internally quite a lot. I don't think we're the only people who use it, but we might be using it in a slightly different way to everybody else, so I can just explain what I mean by it. One way to explain is to draw a picture, but somebody else already drew a picture, so let me just open this handy link from one of the tools that I'm going to be using. Oops, no, that is the wrong link. That is the wrong link. Brilliant, okay. Maybe I've got it here. No, okay, so it's going to be Google. So let me close on just to... And core concepts. See, they know what an inner loop is. So there's a nice picture here. So this is your traditional development inner loop. So you do some coding, you maybe think about things, that takes a few minutes. And then you save the changes and you want to have a build. Maybe inspect the results. See it wiggle is the word that I like to use. I borrowed that from my boss, Brian. And maybe then you will do a git commit. Maybe you won't. Maybe you'll just go back to the beginning. And you go round and round this loop many, many, many times a day. And so you want this to be as fast as possible. And this is sort of what we're used to doing when we're just developing on, local hard metal. The problem is when you start to introduce things like containers and clusters, the inner loop tends to get distorted so that you can be coding for a few minutes, but then it actually also takes a few minutes to build a container and then upload it to a cluster. And so before you can inspect the results, you have to pay this tax of container and cluster. It doesn't matter really whether the cluster is remote or local. So the demo I'm going to do is going to be a local cluster, but it could be anywhere. And so the question really is, are there some tools that we can use to help us to reduce this tax or to avoid paying this tax? And that's the subject of this presentation, really. So an inner loop is where you make a small change to code and you see it wiggle. And I'm going to say that a requirement for me, at least anyway, is that I can use a debugger, because I'm weak. My brain requires to be able to step through code sometimes so that I can see it actually working and try and understand. I use that to understand my code. I use it to understand other people's code if I'm using other people's tools, for instance. So I find that quite important. I like to do that in the IDE. Different people have different IDE preferences, but they're all basically the same. And fundamentally, we need to iterate. We need to make this go as fast as possible. In contrast to that, you might say would be the outer loop. So that's why we call it inner and out. Inner because there's an outer. The outer loop is basically continuous development. So it's when we want to go from pushing a change to a remote repository to production, basically. So I'm not going to talk about that at all today. There are many good resources and presentations on that. I think people have actually concentrated more on the outer loop than the inner loop since containers and platforms and Kubernetes came onto the market. So I think it's now is a good time to start thinking more about the inner loop. And there are people who are thinking about it. So I'm going to show you some tools. So if you wanted to follow through with this and run the code yourself, you could, because you just have to check out this repository from GitHub. And you would be able to, if you could install these things, so kubectl, customize optionally, scaffold, telepresence, and tilt are the things I'm going to use. You can use any Kubernetes cluster, but I'm using a local cluster, which I set up using Kind. So you can set that up, and you can use a little script that I've provided here to set that up, and also a local Git repository so that you can push, local Docker repository, so you can push your containers into a local server. If you are one of the people like me who uses Nix to organize development environments, then you can run it. You can install all of those dependencies and get a command line with everything set up just by typing Nix shell at the command prompt. And so that's what I'm going to do now. Nix shell. If I was doing this for the first time, it would go and download all those things, but I've done that already, so we don't have to wait for that. So it's installed on my dependency, so now I've got things like kubectl is there, for instance. I'm just going to make sure that it speaks Bash, because sometimes it forgets how to do that for some reason. And you can see that it's running, so kubectl get all is the last thing that I did in the script that installed the dependencies. There's nothing in the cluster. It's just a local Kind cluster. So it's running in Docker. It's there. That's the Kubernetes cluster here. Whoops, this thing. And this thing is the local Docker registry that I'm going to use. So it's running on localhost port 5000. All right, so I'm also going to use VS Code as an IDE, which I increasingly do use, especially for demos, but I often use it for non-Java workloads. Java, I'm just starting to get the hang of it, so I'm just sort of transitioning slowly from what I used to use, which was Eclipse, onto VS Code, and using this more and more. And as you can see, I have a bog standard Spring Boot application in this project. It doesn't have to be a Spring Boot application, actually, but I'm going to use some features of Spring Boot, which will sort of make this demo go a bit smoother, but you could probably work out how to do all the same things with any other Java framework. So it's a REST controller. It's going to be an HTTP endpoint, and it's got a home page, very simple home page that says "Hello Spring." Okay, so I can run that. I can run that here in the IDE. Look, I can just do run. That's neat. And just to make sure it works. You could also install a Java JDK as part of that Nix dependency set, by the way. Okay, so it's running. What's the best way to test it? I could just use the browser, for instance. So it's running on localhost at port 8080. And it says, "Hello, Spring." All right, so a feature of in-loop development is that I need to be able to make changes, right? So I should be able to change it to "Hello, JPoint." And that won't immediately be picked up. So I can't see "Hello, JPoint" yet. I need to actually restart the application. So I'm going to, what is it? There is a little widget in VS Code, but I seem to have lost it. Okay, whatever, and I'll just stop it and start it again. There's a restart button somewhere. There it is. Look. Oh, it disappeared. So it must be in here somewhere. I just don't know where it is. All right, I restarted it, and I'm back to "Hello, JPoint." So that, that was a relatively good experience. It took a few seconds, but I can live with that. What I don't want is for it to take minutes and minutes. So that's running the application. But there's some interesting stuff that I can do, which goes a bit beyond that. Okay, so here we are back in the README. So I just I ran the sample out from the IDE. I could have done that from the command line, right? I could have done w spring boot run, and that would work perfectly well as well. So one thing I want to get into is Spring Boot DevTools. And a lot of people who use Spring Boot miss out on this because, I don't know, it's not prominent enough in the documentation or something, but it's very simple. All you do is you add a dependency. So in my POM, I've got this extra dependency, which I've hidden behind a profile. And it's Spring Boot DevTools. It's a runtime dependency. Oops, sorry. When I click too many times on that, it tends to lose the place. I'm just going to go back up. So it's an extra dependency. There we are. Good. There we go. And so I can make that work just by running with this profile, DevTools. Stop doing that. I haven't learned how to use VS Code, obviously. DevTools. All right. So let's just make sure that works. So Maven Spring Boot run -p DevTools. So that sets the profile up, adds the dependency, which means I've got a slightly different class path when I run the app in this mode than when I was running it in the IDE just now. So Maven is doing build, and it started up. And one thing you see is that the main thread has renamed itself. So it's not just main, it's restarted main. And the main feature of that is that if I was to go back here and make a change to that application, if I just change it back to spring brackets chilly because it's cold here, as soon as I save that, the IDE compiles it, puts it in the class path. The application noticed that happened and it started again. And look, it only took half a second to restart. Once it had, there's a timeout, so it waits a second, then it builds and runs. It only takes half a second to restart. So I've got a slightly tighter feedback loop. I'm using DevTools. But more importantly, I've also got a kind of a tunnel. So I've got a way to, if I can make those file changes on a remote system, I can also make Spring Boot do the same thing. So I can use Spring Boot DevTools to drive fast changes in a container in a remote cluster. And that's going to be one of the key features that's going to unlock my inner loop experience on Kubernetes. So, okay, let's get out of that. Let's go README. So that's DevTools. And as I said, the signature of that is that it's got a different, it's got double clicking. It's when I double click that it jumps off. I have to train myself not to do that. Okay, so it changes the name of the thread. It also said, so it works by doing a class loader trick, which is another great reason for having Sergey here, because he's the expert on that kind of thing. It's a class loader trick where it keeps the JVM warm. It doesn't reload any classes that come from libraries, basically. It only reloads classes that come from your application, and then it restarts Spring, and that, because the JVM is already warm, it is very quick. And that actually is quite slow compared to what I normally see, and I'm sure that's because I'm doing a video call at the same time, right? So if I wasn't using Zoom and Speaker Room and all that other stuff, then it probably would have started in like 2/10 of a second or something instead of half a second. Okay, so another thing I'm going to need to learn how to do before I get to a Kubernetes cluster or any kind of remote platform is going to be build a container. So I'm going to do that. There are many ways to do that. In this case, I'm going to use Spring Boot Maven plugin. There's a Gradle plugin that goes with it. And that's going to tick away in the background. And it might take a couple of minutes. So if we had any questions, that would be a good time to start them. If we don't, I can just waffle. And I can tell you what's going on. So we've finished the Maven build and some tests. Now we're building the image. So I'm building an image at localhost 5000, right? So that's the local repository that I showed you. Let me just show you how I set that up. So there's the DevTools dependency. Here's the Spring Boot Maven plugin. I've got a configuration there for the image name. Oh, that was quick. Okay, so I had some caching going on there, so it was quick. So I successfully built that image. I could now run it. So there's one way to run it, right? Docker run, just so that we check that it works. I wouldn't do this every time I made a change to an application. I wouldn't want to, but that's the point of the presentation, really. Okay, so it's running, and I'm sure you'll believe that it's running on port 8080. And it's running without DevTools because I didn't use the DevTools profile when I built the container. Yeah. Okay, so that's what you see when you run a container. If I wanted to, I could build that container with -p DevTools. And then when I ran it, I would have to set this extra property. So I need to tell Spring Boot that, yes, I really do want to enable that restart feature because it tries to be clever. It tries to spot that it's running in production, i.e. in a container from a jar file. And it thinks that it doesn't have to restart. So I have to force it to take note of that. So that's just a little wrinkle there. I'm going to have to take... Sorry, yeah? Do we have a question?
It's a question from the chat asking whether build image is using the build packs, and I think it's a good chance for you to talk about build packs.
Oh, it's good. Yeah, good question. I mean, I did skip over that. It's we're using build packs, and specifically we're using Paquito build packs, which are a set of open source. I guess what they call them is third generation build packs. So if you look up buildpacks.io, you'll find the spec. So a build pack is basically a contract for a container that knows how to build an executable container from some source code. So Spring Boot build image uses those Paquito build packs by default. You could change the builder to a different one, or to your own builder if you had your own requirements. The Paquito ones work pretty well. So you will notice also a good question because there's no Docker file here. I'm not using Docker to do the build. I'm using the local Docker daemon because that's the way that the Spring Boot plugin was written, but I'm not using Docker. I'm not using a Docker file. And that's really the main the main reason I do it, because I'm rubbish at writing Docker files. I much prefer somebody else to take all of those risks and make all of those decisions. So I just want to type Maven Spring Boot build image and get an image. Okay, so I was just explaining that I needed to set a system property. I will need to do that. The reason I'm showing that now is because I will need to do that later if I'm running in a container in a cluster and I want to force that restart behavior to happen. So you can see how that's going to happen. Because running like that in Docker locally doesn't help anybody. Because, well, you could, right? You could find a way to rsync or something. You could have an SSH server or something running inside the container. You could synchronize the changes. You could copy them. But that would be a lot of effort. Unfortunately, somebody else has already done all of that effort for you in a couple of places. And one of those places is Scaffold. So I'll just open that link, I guess, so you can see what Scaffold looks like. Scaffold is it's sort of a workflow command line tool specifically for Kubernetes development. And also, I guess, CI, CD, you can use it for the whole life cycle, in or and outer loop. And it works because it's Kubernetes, it works off a YAML file. And I've got one here called scaffold.yaml. So let's have a look at it. And so it says what version it's using. It says, where is the image going to be? And so I've said it's going to be in my local repository, localhost 5000. And then, so one of the nice things about Scaffold is that it has support for lots of different builders. So one of them would just be a custom build command where you can just run a shell, and then I could run my Maven build there. I could run a Docker build locally as well if I wanted to. So I could do that, but it also has native support for build packs. So this is where you see, I guess, the build packs more explicitly than you did in the Spring Boot Maven image, Maven plugin. But this is actually doing exactly the same thing. So Paquito build packs build a base as a container that knows how to build not just Spring Boot apps, but any Java app, Scala, any JVM app, basically. It also knows how to do Python, Go, Node, JS, Ruby, all those things. So it basically sniffs your code and works out how to build it into a container. And they built that into Scaffold. So it comes from Google, and Google has also contributed quite a lot of build packs to the ecosystem. And okay, so when I do that build inside the build pack for this demo, I wanted to switch on DevTools, so I need to add some build pack arguments. This is documented in the Java build pack. So Paquito build pack / Java build pack, I think it's probably called. You'll see documentation for all the environment variables it takes, and for this one is just a command line. So I want to switch on that Maven profile DevTools, and then I want to package the application so that it can work out what to do with the jar file that gets built. And that's all you need to know for the minute, but let me just show you what else is here. So what else is here is that neat thing that I said. So it has another built-in feature of Scaffold is the ability to synchronize changes from your local machine into a running container on the cluster. And that's what this is for. So this is saying everything under source main resources and target classes, which is where my IDE puts the compiled classes from the Java code. Everything in those two directories is going to be automatically synchronized to the container under a workspace path /workspace/bootinf classes. And that thing there, that /workspace, that's a feature of the build packs. The Paquito build packs in particular tend to always create a directory called /workspace and put the application code in there when it's finished compiling it. So it's quite a short file, short and sweet. I guess I wouldn't want to type that by hand, which is why I'm doing it from a a repository, but it's sort of short enough that it's sort of easy to remember. And the other thing I'm going to tell it is how to deploy my application. So I'm going to deploy my application using Customize, and Customize expects to have a directory. So there's a directory here, source, capes, and a customization.yaml. So the customization.yaml will tell it how to package this thing up into basically a very vanilla deployment and service, and the service exposes an HTTP endpoint. So let me just go back to the script. So I looked at the scaffold.yaml. It's dead simple. At development time, you just do this. You say scaffold dev, and that builds the container, pushes it into the local repository, into the repository that you ask it to, and then deploys it into your Kubernetes cluster. So it's doing the build pack build again, but you only have to do this once, is the point. So that's this is going to be the workflow that we have. We do this once while we to set everything up, get the initial container, get it deployed onto the cluster, and then we should be up and running. Okay, so it's run the tests. It's now built the image. It's loading it into the cluster, so it's pushed it into the local repository, and it's now loading it. It knows about the fact that it's using a kind cluster. So this would work differently if it was a remote cluster. And it's loaded it into the kind cluster. Took a little bit of time, but now you can see I've got a service and a deployment, and there's the Spring Boot app starting up. And you can tell that it's using DevTools because I've got restarted main there, right? So if I was to, well, let's just check that it's working, right? Let's see if we've got a terminal. So I'm going to curl it. So one of the things that Scaffold does when I did this ---- port forward, it sets up, well, let's just make sure that we can see the application in Kubernetes first. So kubectl get all. There we go. So there's a service hello world exposing port 80. And there's the pod that it's pointing to, which is running. So that means that I should be able to curl localhost 4503 is the default for Scaffold. So port 4503 tells me hello Spring Chili. There we go. That's the code that we have just written. But what would be neat would be to watch what happens when I make a change. So let's watch the logs there. And let's go back to just hello Spring. So if I save that change, the IDE compiles it, puts it in the target classes directory. And Scaffold, so you notice that, and synced it over. It copied it very quickly, and then Spring Boot went into its restart cycle. And there we go. It's restarted in just under a second in this case. It's a little bit resource constrained on that cluster there, probably. So here we go. If I curl 4503, then it's gone to hello Spring. So that's, for me, quite a satisfying experience. I do like Scaffold. And you can use it, you can set it up with profiles, so you can do development work, push to staging servers and production. You can separate those roles within your scaffold.yaml. So I quite like that. Another thing you can do with Scaffold, which is very neat, is you can do Scaffold Debug. So if I go back to my this one, let me just stop that. And notice when I stopped it, it said cleaning up. So if you do Scaffold Dev, the point is with Scaffold Dev that it will delete everything that it created when it finishes, which is neat. So kubectl get all now is empty again. If instead of debug, instead of dev, I went debug, then I can do this. And basically, port forward. It's going to do the same thing, but it's also going to expose another port. Okay, so did you see that green writing there? You probably didn't. Let me show you. So it started the same thing, but so it's listening on port 4503 for HTTP. It's listening on port 5005 for a debugger connection. So I can actually do debugging here. I can set a break. There's a breakpoint there, right? I can use the Kubernetes Tooling. Let's just refresh that to make sure it's got the right stuff in it. Kubernetes Tooling in VS Code is pretty good. Here's my hello world. There's the COD. I can right click on it and debug attach. I think it's the right one. So it's Java. It just wants a port, and the port was 5005, wasn't it? Okay, so it's debugging. That means that when I do my terminal curl command here, curl again, curl 4503, yeah. Then here we go, it stops in the breakpoint. So for me, that is quite a nice experience. I could live with that. I don't know what you think. You can have a vote at the end, I suppose. Okay, so shut that down again. The only thing I had to remember there was I have to explicitly switch on the autosync when I do Scaffold Debug, as opposed to Scaffold Dev, where it's the default. Okay, so that was actually all I had time to show for Scaffold. How much time have I got left? Somebody tell me. The next thing I'm going to look at is telepresence. So telepresence is from the Ambassador people, and there was an older version which is still there, and actually if you install from your operating system package manager, you'll probably get version 0.1, I think it is at the minute. Whereas I'm going to show you telepresence 2 because it's new and it's quite a nice slick experience. So we have an image already that we just built with Scaffold, so I'm just going to push that explicitly into the local repository, just in case it wasn't there yet.
And by the way, Dave, you have about 33 minutes left. So thank
you very much.
No worries.
And let's see. I guessed it was about that, but I can't actually see the countdown at the minute because my screen share window. Okay, so this is kind of what Scaffold was doing manually. So I'm going to apply the Kubernetes resources. I've used customized command line there. I could have actually done it with kubectl apply -k. Could have done the same thing because I'm not using any fancy customized features in this app. It's pretty vanilla, so that would work the same way. That would work the same way. So let's check with this there. Kubectl get all. There we go. There's our Hello World service, and it's running. So the neat thing here is that telepresence is just a little sort of worker that sits on my laptop. So I do telepresence connect, and it asks me for sudo access. And what it's doing is it's installing its own namespace and a bunch of stuff there, and you'll see what it does, I guess, when I start using it. So there might be a timeout. I've already set this timeout, and then basically you get to intercept all of the services. So I can do list, and it'll tell me which services are running on my cluster. So Hello World is there. It's ready to intercept, but the traffic agent is not yet installed. Okay, so what does that mean? That means I haven't done this yet. So I need to tell it to intercept the Hello World service using local port 8080 and remote port, which is named HTTP. And the reason it's named HTTP is actually in my config file. So let me just show you that. So the deployment of that Hello World service has a there we go, named port HTTP. So that's the one that's in the service. So when I ask telepresence to do that, it installs a sidecar into the remote pod. So here we go. It's terminated my original Hello World pod, and it's created a new one that's actually got 2 containers in it. So it's got my container, which it will use at its discretion, I suppose. But what it's also got is another one that's just listening there, listening for traffic and managing the traffic between my app and the rest of the cluster. And what's neat about this is I can now just go and where's my action run? I can go and make my change here. Let's just go back to hello St. Peter's. All right, so if I was to just run that, or even debug it, right, just my normal IDE workflow. So it's now running locally in my IDE on my laptop. But what telepresence has done is it's taken the Kubernetes DNS and wrapped it around my local host, so I can do this now. I can do hello world and get back. Oh, look, it stopped at the debug point, so I need to play hello St. Petersburg. So I've got my local application is running, but it feels like it's running in the cluster. All right, so anything that's in the cluster that wants to contact my application can do. And also anything running locally that wants to connect to it can do through exactly the same DNS names as you would use in the cluster. So that's it's not the end of telepresence, but that's kind of what makes it interesting for me. It means that I can just use all my local development tools, all my local experience and debugging and habits, and it just works. And it works pretty well also with a remote cluster. There's no extra configuration files or anything like that. It's just, it just feels like it's running in the cluster, but it's running locally. So let me stop that again. Stop running that. Go back to the README. So basically anything that was running on port 8080 now looks like it's running in the cluster. So you can use Kubernetes DNS, you could use .default there for the namespace, .default.service.cluster.local for the fully qualified domain name. And then you can switch these tunnels on and off. There are other features in there as well. You can sort of manage part of the traffic, so you can manage different paths. Only some paths can go to your local laptop, the rest can go to the container that's still running, which is why it's still running, and I mentioned that earlier on. So if I want to get out of that, I can just leave the Hello World cluster, and I can tell telepresence I don't need it anymore. So let's clean it all up. Yeah, there's a good getting started tutorial on the telepresence website. So I'll just briefly mention, I won't demonstrate telepresence 0.1 because you might get that if you just install it on your, brew install or apt-get install or something like that. So using telepresence 0.1 is a similar experience. So you run something locally and it gets proxied by something in the cluster. So in that case, what it does is you say telepresence ---- swap deployment, and what it does is it actually removes your pod and puts in its own, which is then just a reverse proxy, basically forwards all the traffic to your laptop. So it ends up being a very similar experience, but the architecture is a bit different. And I had used this a couple of years ago. It's been around for a while. So they've had a lot of experience, and they've decided that a better architecture is telepresence 2. So I'd probably gets, if I was getting started now, I would go straight to Plugins 2. So it's a pretty similar experience. And then that brings us to the last tool that I'm going to demo today, which is Tilt. Have I got anything running? Do I need to stop that application? Okay, so Tilt is, I like simple explanations from everything. So my simple explanation of what Tilt is it's like Scaffold, but instead of YAML, you write Python. Now, I'm sure it's much more complicated than that, and it has some feature sets that overlap and some that don't, but I'll show you the overlapping bits at least anyway. So instead of scaffold.yaml, in this case, you write something called a tilt file, and here is the one that is going to run my application. So it's pretty simple, and you can tell that it's a little bit more friendly than YAML because you can do things like this. You've got functions, it's Python. So, don't double click those. All right. At the bottom here. So I can, for instance, I can tell it how to deploy my application using this Kate's YAML function. And inside that, I could have just put a YAML file location, but instead I'm going to call customize to build the demo file. And so you can basically write arbitrary functions in Python that create YAML and then ship that to the cluster. So there's lots of flexibility there. Some people will prefer that to the slightly more rigid kind of Kubernetes resource feel of Scaffold. And so I'm telling this thing to deploy my demo from Customized. I'm also telling it that when I do that, it's expecting to find a resource called Hello World. It's going to forward the ports. So it's going to forward the port from the pod called Hello World to a local host 8080. So 8080 is going to be bridged to 8080 on my laptop. So that's a bit like if that was 4503, that would be more like Scaffold. So it's going to be listening on port 8080 when I deployed it. And there's a custom build which is using the Spring Boot build image, the command line thing that I did earlier on, basically. And this other bit here is the sync. So when things change, when either pom.xml or anything in target classes changes, then I want you to sync from, don't double click, Dave. I want you to double click. I want you to not double click. I want you to synchronize from target classes to workspace booting classes. So if you remember workspace /workspace was the thing that was created by the build pack for me. So there's a few things to look at here. So let me just start it up. So if I do tilt up, and I haven't forgotten to shut anything down, then that should just work. So I could stream the logs, which I'm tempted to do, but if I do that, I don't get to do the other thing. So I'm going to open up the browser because I've got a nice UI. I'm in. Yeah, right. Didn't really need to do that, didn't we? Let's just copy probably. Okay, so it gives you this nice UI, and you can sort of tell from this I could use it to manage the whole cluster. I could have 50 applications all running in this little panel here, and it's all running from this one tilt file, but I can have more of those. And in that tilt file, there is a resource called Hello World, which is currently updating. It would be nice if it would show me the logs here, but it's doing that build pack build again. It's time to go green. Server ready, it says. Okay, so why don't you show me? Here we go, right. So show details means I would get some logs of the running container. See if I can make it a bit smaller so everybody can see. There we go, the application has started, I believe. Yeah, there we go, just about. And you can see that it's telling me that I can connect to it on localhost 8080. So that's the port forward. Just check that's true. Hello, St. Petersburg. And let's do the whole loop. Let's just make sure I can change Hello, Simply Explorer in the Spring. I'm going to change that. See, it noticed, it copied them over, and Spring Boot restarted the app. So when I refresh this, it goes in the Spring. So that's a nice experience. And if you like that kind of UI, it could be good, I think, if you had dozens or maybe just a few applications all running in the same cluster, all needing to communicate with each other. So it's doing something a bit like Scaffold, but with, I don't know, I guess a different language, slightly different approach, and with some additional GUI resources and stuff like that. You can, I believe, I don't think there's anything else. Yeah, there's some, inspection metrics and stuff like that. So it's a sort of a, it's not just for development time, I suppose, is the way that they would pitch it. As is Scaffold, I suppose, also not just for development time, but sort of a monitoring and management tool as well. Yeah, so we like that. And I don't know. I mean, that sort of sums it up for me. There's more detail that I guess I could go into if I had more time, but I don't particularly need to. I just wanted to give you a sense of what you could do with combination of synchronizing local files to the cluster, Spring Boot dev tools. I think what I would like to see from the Spring Boot team is making that a little bit easier. So if you're looking for future features, maybe in Spring Boot 2.6 or 3.0, depending which comes first, I think we could probably reduce the amount of ceremony involved in doing some of those things. Like, it wasn't very much, was it? But I had to add 5 or 6 lines of configuration here and there everywhere to get it to behave. And I think there are ways that we could automate that. We could sort of detect that you were doing this workflow, right? We could tell that you were running using a Scaffold or using Tilt, for instance, and we could just activate profiles and add dependencies and things like that if we needed to. So I'm expecting maybe we could make some changes like that in Spring Boot. But yeah, that's it. Any more questions coming in?
There is one question from the chat, because some people were not sure whether the idea is to debug in production or just in some shared dev environment, for example. And I think it's a good question because how does it work when you have, let's say, 15 developers doing this, and how they should share the cluster, or maybe they have cluster per developer? How does it work?
I think that's a little bit a matter of taste. I expect there are many places where you would be discouraged from doing this in a production cluster.
Sounds fair.
But whether you have, one cluster per team or one cluster per developer or many clusters per developer, I think it's sort of a matter of taste, right? Because Kubernetes clusters they're kind of a commodity these days, right? There are some tools that you can use that will create and destroy them so quickly that you don't really need to care about the life cycle too much. So I think it's sort of up to people to find what's comfortable for them. But I was really thinking about development time. It's at development time, and I've got a system that's basically too big to run on my laptop. I'm doing it on my laptop for a demo, but really it would be, in my mind, more useful for a shared cluster or a remote cluster that's mine, but is only used for development. Which isn't to say that you couldn't play these tricks in production if you wanted to, but I think probably most people would discourage that. Do you agree? What do you use?
Someone says that this is similar to PHP, and I realized that it's almost like PHP, but it won't cause PTSD to Josh Long. So
yes.
yeah, definitely an improvement.
Yeah, shout out to Josh for loving PHP all these years. So what do you use, Alexei? What's your inner loop like?
Mostly Scaffold, and actually I'm kind of excited about trying this telepresence thing. I think it's quite an interesting one, but mostly Scaffold, and the reason being that I'm not actually using dev tools in a container, so I'm trying to keep container as production as possible. Yeah. So I understand that dev tools, they don't actually modify the application per se. But still, it's a different image, and it makes me feel uncomfortable. So that's why I like Scaffold.
That raises an interesting question. So one of the things that they could do in Spring Boot is to allow the same image to contain different profiles of the application, right? So you could have a production profile and a DevTools profile, and they really would only be different by one jar file. So would that make you feel a bit more comfortable if you could just run the container with a different flag? Because build packs already support that, right? You can have multiple different profiles in the same container.
That's actually interesting. So, well, I mean, to be fair, I just never thought about using DevTools and then just, syncing the class files modified on the fly. And I think it's going to be much faster feedback loop if you just comparing to rebuilding image and doing proper deployment.
For sure. Yeah, I didn't do that demo because it would have taken several minutes.
Yeah. But yeah, as I said, I mostly use Scaffold, and I think I find it quite widespread in Kate's community, and I think a lot of people use that.
I like Scaffold. Yeah, that was my first choice. But we can have a vote if you want. I mean, I think Tilt is sort of newer, so it's gaining in popularity. Right? But Scaffold, I like the way that it supports different build tools quite sort of straightforwardly. Right, you can just copy paste stuff in the documentation really quickly. So I could switch between build packs and Dockerfile really quickly, and it wouldn't take much effort. Tilt it has all the same features, but I guess I'm sort of less familiar with using Python. So you have to be a bit confident with this function, calling procedures in Python to use Tilt. I think it's quite popular in some of the Kubernetes community within VMware. Tilt.
Okay, interesting. There is actually another great question. I'm really not sure how to take this one, so I address it to you. So the question is about build packs, actually, and it's a very good concern. So Artem is asking that, so the build packs are essentially just a set of instructions on how to build a Docker image provided effectively by someone on the internet. So you don't have to write a Docker file, and it's very opinionated and blah, blah, blah. But that could actually raise some concerns from the security team, because effectively it's just a black box. You just produce the image, which is not owned by the development team. And Artem is wondering, do you have any recommendations, or don't want to call it a guide, but maybe some set of recommendations on how to justify usage of build packs, or maybe make usage of build packs more secure?
Well, they sort of designed from the get-go really to avoid that problem in some ways, right? Because there's a clear distinction. It's separation of concerns, right? So there is a different responsibility for building the build pack and building the app. So as an application developer, I really don't actually want to care about all those security concerns. I just want the container to be, to meet the standards of the organization that I'm building it for. And so the best people to do that are not the developers usually. They're usually the platform team, the central tools team, or maybe there's a compliance aspect to it, right? So the point of build packs is that you can gatekeep at the cluster level. You can say, I don't want to accept any containers that were not built by XYZ build packs, right? And so you can say there's only one way to build an app, and that's using my own organization's build packs if necessary. People do that. But most people find that the keto build packs are so convenient and quite well designed already, so they don't stray too far from that. But you can add additional layers, additional builders, and additional build packs into the process. Does that answer the question?
I think so. I mean, let's Artyom actually respond to this in the chat, but I think it sums it up pretty nicely. Yeah,
it's not the most. I don't know. It's not the easiest experience, I would say, building a custom build pack, but it's definitely a thing that they intend you to do, right? They intend the standard of the, security compliance.
I think build packs to Docker images is something like RPM to packages, basically. It's not that simple to build an RPM package. There are some tools that help with that, but the result you're getting is much better than just an archive that you need to unpack somewhere.
Yeah.
Correct. Yeah.
I mean, maybe just to add to that, to this security concern, is actually that you don't have to use a public build pack from the Docker from Packeter. Let's say you can fork it. You can have a private copy which is inspected by your security team and only upgraded by your security team, and it like fully controlled and constrained within your organization. Like there's plenty of possibilities. Like it doesn't. It's pretty much to GitHub and your own Git repo within your company. Like you can use something from the GitHub, but you can fork it and then keep it local as well.
Well, you can automate it in the cluster as well, right? So there's this thing called Kpack, which is a Kubernetes native build pack server. Basically, it just sits in the cluster and watches source repositories and does the build in the background. So that's all outer loop. So I didn't want to get into all that, but if you're thinking about actually getting to your container all the way to production, then you probably need an outer loop as well. And I suppose one of the concerns that I had was that my inner loop is as similar as possible to the outer loop. It can't be the same because the outer loop just takes too long. But I want to make it as similar as possible, and so build packs are probably the way that I want to build my outer loop, so I should use it on the inner loop. If you don't like build packs, actually most of what I've done today would work without them. I find them quite a useful, convenient mechanism to get from a Spring Boot source code to a runnable container. So if you don't like doing it that way, there's nothing about the inner loop experience that I've described depends on build packs at all. Right?
Frankly speaking, I'm surprised that the question of security was someone asked the question of security when we were talking about build packs, because all I know is that build packs actually improves the security and help with that. So someone asking but isn't it worse security-wise? No, it's better.
No,
actually.
It's better.
I think as I understand, the concern was not so much a security, but maybe more like audit perspective and having more control over it. So, which is totally possible. Again, you can just create your own copy of the build pack and then restrict it to the version you want, and then just have it a local copy if you want, and modify it in any possible way you would like.
If you give your developers access to Kubernetes APIs, then they can probably do lots of things that you don't want them to do anyway, right? But there are ways to gatekeep that. That's definitely outside the scope of what we're talking about here. Yeah,
there's also a question. But there's also a question whether it works with OpenShift or not, and I would assume yes, because that's just a Docker image. Maybe you can talk more about it.
I haven't explicitly done it with OpenShift, but I don't see any reason why not. OpenShift is, to me, in my mind, it's just Kubernetes with some extra security and authentication layers, right? And so I don't think there would be any problem doing exactly the same workload on OpenShift.
I actually checked, and it does work with OpenShift and their system, source to image. It also supports build packs. So source to image is a similar approach in OpenShift, but since Pivotal and other companies like Heroku and others start working cloud native build packs, it seems that they just want to use the same
technology. And build packs are becoming quite, like I said, Google are promoting them as well, so they're becoming quite common. And another way that build packs help you with security, I mean, this is sort of off topic, another way that build packs help you with security is they let you replace the lower layers of a container, so the operating system layers, can be replaced independently of the higher layers. There's some fancy name for what the contract is between the higher layers and the bottom layers, which I can never remember, but you can basically have a heartbleed security vulnerability, for instance, where you need to patch the operating system essentially, and you can just do that in an automated way. You can have thousands of apps it might take a week if you've got thousands of apps, but you can automate a rolling upgrade of all of your applications without actually changing any application code or even going through the CI process, right? They literally just take the bottom layer of the container and replace it.
Yeah, I don't think you even need to rebuild your application classes or anything. Exactly. It's literally just another layer,
Yeah. Because the layers are actually just binary blobs, right?
Yeah.
There is a question that I feel obligated to ask. How to run tests with this approach, and does it change anything or not?
I guess it depends on what the test is. You can run your unit test just on your, locally in the IDE like you normally do, right? If you have, acceptance tests or end-to-end tests that where you need the other service components in the cluster, then I would be quite interested in looking into how I could do that with something like Scaffold. What do you do, Sergey? Alexei, with your in-cluster testing?
Yes, Alexei, what do you do?
Yeah, so we normally just, start spinning a cluster, something like kind cluster or a proper cluster if we need to, then just use Scaffold run to actually deploy stuff in there, and then just run acceptance tests, because we only need a cluster for acceptance tests for proper end-to-end tests, right?
Yeah.
And we just run it externally, so for the test suite, there's pretty much no difference if it's within the cluster or anywhere else.
Yeah,
it's just an external URI, right?
Yeah. Right.
So I wouldn't say it changed using Kubernetes changed our approach. We always prefer the black box testing. So, that helps a lot to kind of abstract out from the implementation.
So, and certainly that thing that I showed you with telepresence where it maps the cluster DNS onto your laptop helps a lot with in-cluster end-to-end tests, right? Because you can basically run the same code locally as if it was in the cluster, and that is actually a really nice experience.
Yeah, I think it should be really cool, especially when you have some.
Go ahead.
When you have a certain components which are you cannot run locally. There's plenty of them. You cannot plenty of components you cannot deploy locally. You can only run it in the cluster, or maybe it's already running in a cluster, and then telepresence is just actually a real gift. So you can just run your code literally next to your production, or not necessarily production, your cluster basically.
Yeah, cool. But something that's always running. Yeah, I could imagine doing that in a shared team. You might have to sort of coordinate who's using which deployments sometimes. But yeah, very interesting. Sorry, Sergey, did you have another point?
Oh, no, I just wanted to mention that the rumor says that integration testing remains a good approach to test your applications when you want to be more precise about what you're testing. So perhaps it doesn't change much when it comes to integration testing, but it does indeed help with end-to-end testing and system testing or acceptance testing in your case.
Yeah, I think that's the right way to phrase it. Yeah.
Okay.
Cool, and I don't think we don't have any more questions in chat, so I think that's pretty much it.
That's a wrap. Cool. Thanks for coming, everyone.
Yeah, okay. Thank you very much.
Anything from you, Alexei F?
Yeah. Yes, I want to say a big thank you to all of you for this talk, especially for David, of course, and all our attendees. Please push the Zoom button just under the player to follow the upcoming discussion zone with David, Alexei, and Sergey. And again, it's a great honor for all of us, for our team, for our attendees to have you on board this year. Thank you very, very much. And see you a bit later in Zoom.
Cheers.
Okay. Bye-bye.
Bye.
Thanks, everyone. Bye.